Christina and Alexander, and today we're going to explain you a problem that has to be with related rates. It's a problem that we have to solve. For this problem, refer to the figure of baseball diamond, which has side of 90 feet. Runners start at first and second base. When the baseball is hit, the runner at first base runs at a speed of 18 feet per second toward the second base, and the runner at second base runs at a speed of 20 feet per second toward the third base. How fast is the distance between runners changing in 1 second after the baseball is hit? So this is how the problem looks like before the baseball player starts to run. Each side of a baseball field have a measure of 90 feet.
Okay, now I will explain the picture. The first runner runs 18 feet. So we can subtract 90 from 18 and we get 72. The second runner runs 20 feet in 1 second, and that's why B1 is 20. We then use Pythagorean theorem to find the distance between them.
Our givens in this problem are time, which is 1 second, dAdt, which is 18 feet per second, and the last one is dBdt, which is negative 20 feet per second because it's going downwards. The problems ask for dCdt. Also, another thing, this one, C1, we'll look it after we look for A1 and B1. After we look for A1 and B1, we can solve for C1.
First, we find an equation that relates to all variables. Then, we find the derivative of this equation. After it, we replace, and here's our formula. We replace the givens in the formula. 2 times 72, which is A1, times 18, that is the rate, plus 2 times negative 20, because the runner is running downwards, times 20, that is the distance, that is equal to 2c times dCdt. So it's 2592 minus 800, that is equal to 2 times 74.7 times dCdt. We subtract and it gives us 1792 over 2 times 74.7, and dCdt is equal to 11.995 feet per second.